In today's Cutter Consortium webinar, Mike Rosen will present an overall enterprise architecture that incorporates the many different perspectives of the cloud, addresses the range of issues, and describes a framework to govern what can be moved to the cloud, what should not be moved, what IT should do proactively, what the business can do on its own, and what it must coordinate with IT. Mike Rosen is Director of Cutter Consortium's Enterprise Architecture Practice and Senior Consultant with its Business IT Strategies Practice. He has more than 30 years of technical leadership experience architecting, designing, and developing software products and applications. Currently, he provides expert consultant in the areas of EA, SOA, and business architecture. Mr. Rosen has extensive experience in software development, including roles as CTO, Chief Enterprise Architect, Product Architect, and Technical Lead for various firms. He is a frequent technical speaker and author, presenting keynotes, tutorials, and seminars at conferences in the U.S., Europe, and Asia. In addition to dozens of articles, Mr. Rosen is co-author of the books Applied SOA, Architecture and Design Strategies, and Developing E-Business Systems and Architectures, A Manager's Guide. Welcome, Mike.
Thanks very much, Mark, and welcome everybody. Thanks for joining. What I want to talk about today, it's the abstract had a lot to cover in an hour. I'm not sure I'll get to every item in there, but what I'm going to talk about is first, let's level set what about the cloud am I talking about in this seminar, and what's an architectural approach to integrating that into the enterprise. Then we'll look at important issues, spend specifically a little bit of time on availability, security, data, and then look at a decision framework for helping frame those issues in an architectural perspective that we can use to interact with the business around. So there are lots of definitions of the cloud, and there are very many different aspects, and not all of them are relevant to my presentation today. So I'm not really concerned whether we're talking about a public cloud or a private cloud or a hybrid cloud, and really not talking about virtualization. Everybody's doing that. Architecture is already in place with virtualization. Where I think the biggest impact might be from the cloud is in terms of the services. So what I've called X as a service, whether it's infrastructure as a service, platform as a service, software as a service. These are things that our business is going to depend on, but that we don't own or manage or control. And so we need to get in front of these things as architects to make sure that services that we bring into our enterprise add value to the enterprise instead of adding complexity or complications. Here's an example of some of the different kinds of offerings in the cloud. So we have software as a service, things like ERP from NetSuite or CRM from Salesforce.com, probably the most famous one. We have platforms as a service, so we've got general platforms like Microsoft Azure, or BPM platforms like Appian, or specific platforms like Force.com that allow you to add capabilities onto the Salesforce suite. And then there's a whole set of infrastructure as a service that provides scaling, provisioning, where then there are a set of metering, billing APIs that we use to take advantage of infrastructure as a service. And these are the things that we really need to be concerned with from an architectural perspective. There are lots of claims about cloud computing, that it's cheaper, that providers host the service and the cost is aggregated, amortized across multiple users of the system, that it's quick, that the cloud services work out of the box, or that it's faster to provision things on the cloud than in-house. I think cheap is probably true. Quick, I'm less convinced about in some certain circumstances, but nonetheless, it's a claim. Up to date, so certainly the cloud cloud providers are keeping their software more up to date than typically we would ourselves. Scalable, the cloud can grow very quickly, cope with sharp increases in workloads, and those peak workloads are one of the major use case scenarios that enterprises have for cloud computing, and that by its very nature, cloud computing is mobile. So those are our typical claims. And so when someone hears those claims, what do they think? Well, the IT guys hear about the cloud and think, okay, this is good. We're going to do hybrid. We're going to have a hybrid cloud, and we're going to virtualize stuff, and we're going to use the infrastructure as a platform to provision things, and this will be fun. The business guys are thinking something often very different and, to my point of view, very dangerous. They're thinking, I don't need IT anymore. I can just get everything I need myself on the cloud. Now, if that is in fact what happens, I think we're going to have some problems. Here's a view of IT architecture. So sometimes, we have enterprise systems, and we can think about the technology architecture that they run on, the information architecture that describes their data, the application architecture that describes the architectural styles and patterns, as a view of the IT architecture. Obviously, there's something missing from that picture, and what is it that's missing? It's the systems, the IT systems that are not covered by the architecture, that are not part of IT, typically what we call shadow systems. These are desktop systems, custom-built things that a little group did that never involved IT. And maybe you don't care about that. I would say that those shadow systems actually provide a huge amount of risk to the enterprise. So on the left, the shadow systems, well, there's very low cost to procure, but the shadow systems are unaccounted for. They provide a high amount of risk to the system. What are the risks around? Well, the systems aren't managed. Operations doesn't know about them, doesn't take care of them. There's no help desk support for them. There's no guarantee of availability or reliability. If those systems become important, they can't scale. They're not integrated into the enterprise or with any other system in the enterprise. The data on them is not backed up. There's no disaster recovery or business continuity planning associated with them. There's little or no security. There's no entitlement systems in place to make sure that the wrong people don't access information. They're not tied into any systems of compliance or auditing. And as the systems get old, there's no technology refresh associated with them. All of those things are things that we want, that we as architects and as technologists understand are important, but raise the cost of a system. So sort of at the other end of the spectrum, we have these enterprise class systems that we own and manage. There's a high cost to procure, but the risk is reduced. And so the question that we want to ask about the cloud is, where in this spectrum of cost versus risk are these new cloud systems going to come in? When we bring in a software as a service, are we going to have help desk support? Will we have disaster recovery and business continuity planning? What will we know about security? How will it tie into our auditing and compliance? So those are the kinds of issues that, as architects, we want to get in front of and have some guidelines for, so that we can guide the acquisition of cloud services into our enterprise. So what's an architectural approach then to this? Well, first, it's understanding this big picture from the enterprise perspective, right? Infrastructure services are not just in isolation. There's part of the entire enterprise. And when we bring in a new infrastructure as a service platform, or a new software as a service, or a new platform as a service, it needs to add value to the enterprise and fit into what we have, rather than adding complexity. So before we bring something in, we want to examine the full range of issues. Now, one of the main goals of architecture is in achieving commonality across some scope in order to meet certain requirements. And we talked about reducing the risk of systems and that there was some set of requirements around security, integrity, semantics, compliance, auditing, backup, disaster recovery. And as an enterprise, we don't want 27 or 200 or even 5 different ways to do all of that. We want there to be a standard way across our enterprise to understand security issues or to have common semantics or to do compliance. So our architecture for the cloud has to say, how do we address these issues for the cloud? So architecture is gathering the requirements. We've been talking about gathering the requirements, defining what has to be common. This set of things is a subset of all of them. And then coming up with some specification and document that describes what those common things must be and how something complies with that commonality. Often that's where we stop in architecture, and if we stop there, we don't deliver the value that architecture needs to deliver. So what we need to understand is what are the processes in the enterprise that are involved in bringing in cloud-based systems, and how can we integrate these guidelines into those searching, procuring, contracting processes so that we influence the selection of cloud things as opposed to try to stop them later on. Right? And one of the best ways to do that is in terms of some kind of project assistance and consulting, and then in communicating what are the issues and what is it that as a business, as an enterprise, we need to do to get the most value out of the cloud while eliminating or minimizing the risks that it might present. So what are these issues? Availability, security, incident management, accountability, semantics, integration, compliance, visibility. We're going to talk about a few of these in a little bit more detail. Some of you might have seen a web page like this a couple of weeks ago. Major Amazon outage ripples across the web. Right? It was about a week before we actually heard anything about it out of Amazon. The BBC reports that Amazon apologizes with the English-British spelling there for cloud fault a week after it actually happened. Disruption knocks customer sites offline. Really, it was very interesting. A couple of things about this were very interesting. One is that everybody held Amazon up as sort of the gold standard in terms of infrastructure as a service. And so the fact that Amazon could be wiped out, that its availability regions could actually not work correctly, that availability zones, that it could actually extend across regions, was a wake-up call to many people. There's a very interesting about 10-page article written by Amazon describing exactly what happened, but basically what happened is that they have clusters of systems, especially of their storage systems, and there's 2 networks in those clusters, a high-speed data network and a sort of a lower-speed out-of-band control network, and they were upgrading the network router, and they accidentally, instead of routing all the traffic to the slow-speed network temporarily, they accidentally turned both networks off, and that caused an error which rippled into a bigger error, which rippled into a larger error, which rippled sort of into an endless cycle of things trying to reconfigure themselves. Really quite an interesting story. The thing that I read a lot of different articles about this, and the one I'm not going to name the analyst who said this, but an analyst said customers need to start asking tough questions and to not assume things will be taken care of, because they will not. They shouldn't be counting on a cloud service provider like Amazon to provide disaster recovery. Why would I move my stuff to the cloud if I couldn't count on Amazon to have their own disaster recovery? I'm just dumbfounded by that statement, but certainly this is an issue that we need to be aware of. So what do we expect the cloud platform to provide us in terms of availability and reliability? Often we use those terms, so just to clarify, availability is the time that a service should be available. So we say 24/7, it should be available all the time. Reliability is the actual amount of the available time that it is available. So 99.99% reliability. Now, fault tolerance is easy, or the principles in implementing fault tolerance are actually fairly easy. The principle is never have only one of anything. It's very easy to say, but implementing that is really, really, really hard, right? As Amazon discovered that they didn't have, had not tested certain error conditions, and that cascaded into quite a problem for them. So the point of this is that we need to understand the limitations of these cloud providers, and we need to have good service level agreements in place that are in line with the requirements that we have for the systems, that give us the ability to view the performance of the provider against our service level agreements, and where we have penalties in place where those agreements aren't made, and perhaps rewards in place where they're exceeded. Now, many of you will recognize this picture. If you don't, perhaps you'll recognize this picture. This is the Deep Horizon oil spill from last year. What was the result of this? Well, this was devastating to BP, at least for a while. Deferred their dividends for a year. Their stock dropped by 50% in just a couple of months. And what happened here? Well, BP was the owner of the well, and BP outsourced the well to the platform to Transocean, and Transocean outsourced the blowout preventer to a third company that BP is now suing, right? And it's really interesting. I read the stories about this as well, and there was an interesting one from CNN News, and it said, in discussing the leaks of the blowout preventer, Cameron, which is the company that owned it, identified 4 problem areas. First, the leak deprived shearing rams of sufficient power. Okay, who cares? The second one, this is one that happens in architecture all the time. The blowout preventer had been modified, but the drawings that BP depended on did not match the modified structure, right? So how often in architecture do we have architecture that's put in place, and then things get changed, and we don't keep track of them, and then something goes wrong, and we can't address it? Now, what's the point of all of this? Well, stuff happens, right? Disasters happen, and they're going to happen to your cloud provider. And when something happens, is it BP pointing the finger at Transocean, which is pointing the finger at Cameron? Is anybody in charge? Who do you know? Who do you call? Who's going to be in charge of your incident management? Who will be responsible for you ensuring your business continuity? will you have any visibility at all into the situation? When the Amazon cloud went down, did any of those websites that were off have any visibility into what the problem was? So you need to take all of this into account now in your new disaster recovery and business continuity planning. You want to have this integrated into your contract with them, and you still want to practice your incident response. I'm not a lawyer. Looks like they're getting involved. I think you're going to want a really good service level agreement around business continuity as well. What about security? You don't have to look too hard to find security incidents that have hit the internet. So these are from a year ago. Citibank loses $10 million to cyber thieves. RIM software upgrade leaves BlackBerry users stranded for days. I love this one. The Department of Defense reports that Iranian militia have been intercepting video feeds from its drone aircraft. And I don't know how many of you, read about that in the news. They were doing it for over 6 months. The DOD actually knew that they had a vulnerability, but they said, the Iranians are not sophisticated enough to figure out how to do this. How they actually did it was they bought some spyware off the web for $30 from a provider in Russia. Right? Albert Gonzalez, recently sentenced 25 years for stealing 135 million credit cards. How'd that happen? He was a subcontractor to the Secret Service, and while he was working for, I believe it was Visa, but who knows which card processing, he stuck a sniffer on their network. Right? Again, what's the point of all of this? Well, these are sophisticated, high-quality, well-financed organizations. Right? And if this happens to them, it's going to happen to software as a service providers, right? Another case, Zeus Trojan steals $1 million from U.S. bank accounts, and this is a fairly complex scenario, unfortunately one that most antivirus catchers don't catch. How do you create these Trojans or malware? Well, there's a whole industry around this. So now there are things that you can buy on the internet called Crimeware kits. And the most famous, the one that we just saw, is the Zeus 21 kit. It can be purchased for about $600, 400 British pounds. And that kit allows you to create these bots that target specific users, typically, that then you send an email to them. It seems very legitimate. It's targeted very closely to them, typically someone with money, and they click on the link, and that puts the bot on their computer, and now that computer collects the data and logs into their account and transfers money in very clever ways. In fact, it transfers like $9,900 at a time, so the transfer is below the dollar amount that needs to be reported, for example. And it's not the bank's fault. The bank isn't involved at all, so your money is gone. Now, this was so successful that a different crime organization came out with a different product, which is called SpyEye. So now, instead of Zeus, you can buy SpyEye. It's a better and more sophisticated. And as well, I love this thing. If it detects that you have Zeus on your computer, it intercepts Zeus's communications. Again, what's the point of all of this? It's not high school hackers that we're worried about anymore. There is organized crime on the internet who's got nothing better to do than to steal your data from you or your software as a service provider. So we want to ask some basic security questions, right? What are our important assets? And then how do we adequately protect those assets? So we want to have some strategy, some defense in-depth strategy. We want to understand the strategy that our service provider has. The next two questions are, how do you know when someone is actually messing with you? Right? So it's not enough to protect your assets because those protections are going to get broken. You need to know when those things are broken. And then finally, how agile are you at dealing with it? When an attack is detected, can you stop it? So how do we answer these questions differently when a cloud provider is involved? We still have to ask the same questions, but now we're going to have a slightly different set of answers. Luckily, there's some help in this space. Clearly, this is an area where there's been a lot of criticism of the cloud, a lot of publicity, and there's an alliance, what's called the Cloud Security Alliance, which has been put in place to help us manage these things. The alliance has a stack, they call it the GRC stack, Governance, Risk Management, and Compliance, and that stack is made up of 4 components. The Cloud Control Matrix, and the Cloud Control Matrix is a set of security controls and a framework for how all those security controls fit together and are applied across a variety of different security domains, and then they're related to industry security standards like ISO 2701 or 2702. The Consensus Assessment Initiative is a way for providers and consumers of cloud services to have a fairly common approach to assessment of that provider. One of the first deliverables out of this is a spreadsheet that has a set of standard questions for consumers and auditors to ask cloud providers. Cloud Audit is a way to automate the audit, assertion, assessment, and assurance of software platform or infrastructure as a service environment, and provides an open, extensible interface and method for doing so. And then CERT is Security Incidents Response Team. There's an Internet CERT, and the idea here is to have a cloud CERT, so an incident response team that's supported by the major cloud providers to prepare for and respond to vulnerabilities and threats and incidents so that they can preserve the trust in cloud services. So this is certainly something that you want to look into. You probably want to take advantage of the assessment initiative and the control matrix immediately. These can be downloaded right from their web page. And you want to make sure that your cloud provider is participating in these things, and particularly in the incident response team. Now, one of the typical architectural principles that we have in enterprise architecture is data is an asset. Data is an enterprise asset. And that's certainly true. From a cloud security perspective, data is a liability. Right? And we've certainly seen examples where just very recently from Sony, for example, where data has been lost, and that's a huge liability to a corporation. Theft of information has surpassed all other kinds of fraud as of last year, and this can be really expensive. I don't know how many of you remember the scenario a few years ago with the TJX company, the parent company of TJ Maxx, that reported they lost 45 million credit cards accounts. Well, it turns out that that was actually 94 million accounts, and the way that those accounts were lost was that they had not updated the security on their wireless network. Now, what this reports is that the banks were suing TJX to recover the cost of reissuing 94 million credit cards. to reissue a credit card. You can do the math here. That loss of data cost TJX $850 million. Right? Data can be a huge liability. So data in the cloud, our approach to this has to be consistent with one of these security principles, which is called deperimeterization. Deperimeterization says that we can no longer secure our assets by securing our perimeter. Our perimeter is so full of holes that it's useless, that we have to secure our assets in place, in use, in transit. And data is a specific kind of asset that we need to secure. So our approach to data security has to take into account that we can't secure it by securing its perimeter. Protect data in rest, in use, in transit. There are some other complications. Many countries have specific regulations on where the data has to reside. It may have to reside in that country. And so this is going to be a consideration that we have to take into account. There's more than one kind of data. Not all data is created equal. Typically, we have a few characterizations of data, 3 or 4 levels. I've seen a 3-level, low, medium, high, or 4-level, public, internal, private, and confidential. And these characterizations take into account the sensitivity of the data, the risk if it should get lost, regulatory requirements, how much it needs to be available, the performance we need in accessing the data. And here are some examples of typical data that would fall into this high or confidential category, what we call PII, personally identifiable information, such as social security numbers or credit card numbers. Certainly for a company, intellectual property is highly important, or confidential, such as data such as medical records. And so we want to have some way to categorize the information based on these sensitivity risk regulation and come up with some structure for identifying the data. Given the risk or categorization of that data, then we may have a different approach for how we're going to secure it and whether or not we're comfortable at this point in time in moving that data to the cloud. I like this classification policy. This is a sample policy that comes from Stanford University. And so you can see that they've, looking at data, what are the legal requirements associated with this? What's the risk to our reputation, other risks to our institution? Who is allowed to have access to the data? What are example types of this data? And so again, this is a good example of a data classification policy. While we're talking about data, we might ask the question, what's the data look like? What's the schema of our data that's in the software as a service provider system? Do we know? Can we find out? And how does that relate to other definitions of the same data that we might have in our enterprise? If this is data about customers, we've probably already got customer data in our enterprise. Are we going to need to integrate these things together? What amount of transformation is going to be required to integrate that customer data in our software as a service provider with the rest of the data in our enterprise? Is this data part of some master data management or operational data store, or data warehouse, or business intelligence implementation that's underway or already in place? Worked for a client that had done a really, really extensive customer information service project. So they started with just a couple of different lines of business. Each line of business in their retail banking had different customer information systems, and they integrated it together through an SOA service about 10 years ago, starting about 10 years ago. And then over a period of time, they added more and more lines of business, more and more data sources into a much larger customer information service. And this is something that took about 5 years, and they spent over $10 million to achieve this hugely integrated customer information service with 80 different products using that service. Then, a different organization, who will remain nameless, went out and got Salesforce.com. And guess what? They added customer information to the mix, and that customer information is not integrated with the rest of the customer information in the enterprise, right? Maybe that was a good thing, but I'm thinking if I'm the executive that spent $10 or $20 million to do this over a 5-year period, I would not be real happy about someone just going off and bringing new information into the enterprise that countermanded what I had just done, right? So again, information, I think this is going to be, this integration of semantic information is going to be one of the biggest issues that the cloud provides to architecture and enterprise architecture in particular. Software as a service is going to introduce new data definitions into the enterprise. Business intelligence is becoming more and more powerful and common, and as that increases, the demand for integrated data increases. Our role in IT has been transitioning and continues to transition from developing specific solutions to integrating solutions that we acquire, COTS applications, outsourced applications, and now cloud services. And so in terms of the data, as architects, we need to identify the specific enterprise entities that have to span the systems and services, define them in terms of an enterprise information model and their schemas, and have standards for information and service integration, and some common infrastructure for transformation, integration, data movement, aggregation, and decision support that accommodates the kind of data integration we've done in the past, and now the new integration requirements that cloud computing are going to impose on us. Now, we want to minimize the amount of that we're doing. So what we might want to have as architects is some kind of a planning approach. So here is a sample planning matrix. Architecture is responsible for simplifying the complexity, reducing IT costs, lots of different kinds of complexity and costs, such as data integration. And the way that we do this, or one of the ways, is identify the things that need to be common. So here is a list of things that we want to be common across the cloud, and we then use this matrix to describe the requirements for commonality. Right? And again, as we bring in new services, we don't want to make operations more complicated and more cost-effective. So how are we going to monitor that new thing? How are we going to monitor the security? How are we going to know when someone's messing with us? How are we going to know that it's always running? How is that going to fit into our auditing? Will we be able to know who did what to what and when? What regulations will apply, and how will we verify it? What will be logged from this thing, and will we be able to access those logs? And then what will be our disaster recovery and business continuity plans? How will that be performed? What will be the relationship between us and our service provider in response or respect to the disaster recovery and business continuity? In terms of architecture, we're going to need to integrate the platform or the service into our environment. Maybe we need to integrate it into our SOA environment or our business process environment. Certainly going to need to do information integration. So we want to know what that means and what's going to be involved there. And then in terms of financials, we want some way to monitor this information or monitor our contract with the software service provider, make sure that it's being met, make sure that we know that it's being met. And we want to also have some common contracting and engagement, right? If we have 10 lines of business all buying the same software as a service from the same provider. We'd like to actually buy it once and use it 10 times instead of buy it 10 times, right? So this is just an example of some of the architectural questions that we want to ask, and then the requirements that your enterprise, my enterprise are going to have are going to depend on the answers to the questions. We also might have a decision matrix that helps us identify the acceptability of cloud solutions. So sort of along the top, yeah, cloud is a fine solution, or let's evaluate this to see whether or not it's a good idea, or no, the cloud is not a good idea. And along the side, the different characteristics that we might want to examine. Again, availability, disaster recovery, security, classification, semantics, regulatory requirements. So again, this is just an example of how we might apply that matrix for our enterprise. Then, given these two matrices, we have the ability to engage with the business to help them understand the issues of the cloud and what's acceptable, what they can go ahead and do. Anything in this fine category, okay, go ahead. Anything in this evaluate category, well, we probably want to help you figure out the right solution. So as architects, we also want to provide some set of consulting services or architectural services to our business partners to help them in choosing the right cloud services. So we might want to have some service around requirements assessment, again, where we specifically assess against these and these set of requirements. We might want to have a security assessment and design service for them, or again, assessment and design around disaster recovery, around integration, capacity planning, and load, and perhaps some evaluation of the service providers. So it's not a question of whether the cloud's coming. The cloud's here, right? And the business is going to use the cloud whether we like it or not. But the cloud has issues, and we've talked about availability, security, accountability, integration as some of the particular issues of the cloud. As architects, we need to get in front of this so that we're ready with guidelines and standards and services, and we can help the business choose the right cloud services so that positioning the cloud provides value and agility and reduces costs as opposed to providing complexity and risk and increased integration. So sort of the last question here is, there are lots of problems with the cloud. Amazon, the recent Amazon example, a perfect example of that. But could your organization actually do any better for equal or less cost? And the answer to that is probably not, right? The cloud is going to provide an option that we want to take advantage of. But as architects, we want to take advantage of it in the context of the enterprise and the context of all of these other issues and all of the other things that we have in place so that we increase value and not increase complexity. So that's my pitch today, and thank you for listening, and I guess at this point we'll take some questions.
Thank you very much, Mike. At this point, we would like to move into the Q&A session. To ask a question, just type it in the bar at the bottom of the Questions for Mike pod and then click on the speech balloon to the right of that bar. So, Mike, our first question is, what is the biggest risk the cloud presents to architecture?
So I think the biggest risk to architecture is this opinion from some of the business people I've talked to that the cloud is a way to not have to deal with IT anymore. And so so we have this potential of going back to the bad old days of unmanaged IT and going back to the risk of more shadow systems, right? If IT is not involved in bringing in, or someone, at least architecture, is not involved in bringing in these cloud solutions, they will be unmanaged, and we'll have all the same issues that shadow systems provide. So we want to prevent that. We know we can prevent it. We're at the time and place right now that we can actually get in front of it.
Great. So the next question are there any guidelines or principles from the business perspective?
Guidelines or principles from the business perspective. Well, I think that this matrix that I was using here, if I can get, these are many of these are business questions, right? What's the availability of the system that you need? How will you do disaster recovery? What are your security requirements and regulatory requirements? So I think that from a business perspective, we want to understand the risks of the cloud, and we've talked about some of them specifically here, and be able to make a trade-off of what is the risk, and is this an acceptable risk in the business terms?
Okay, great. The next question, are there any hard and fast thumb rules on whether to cloud or not to cloud?
Well, like a consultant, as a good consultant, there's only two possible answers. The first one is that depends. So I guess I'd have to say no. There are not really any hard and fast rules. Personally, I think that I'm personally not comfortable yet with moving that most confidential data out into the cloud. Right? So I might put a rule in place that says let's not move that kind of data out into the cloud. There's some things that are obviously good solutions for the cloud. So, for example, Cutter is an organization with just a couple of dozen employees and a network of consultants. And 10 years ago, Cutter could never get the capabilities to do webinars because you had to bring that in-house, and it had to be, a dedicated unified communication server, and it cost millions of dollars. And now today, Cutter or, a two-person company can do webinars because this is hosted on the cloud. So, again, that's sort of a no-brainer. That's obviously something that ought to be hosted on the cloud. There's a lot of gray area in between.
Mike, what is the most important takeaway from your presentation?
Well, I'm not sure there's a single takeaway, but probably there's two takeaways. One is that the cloud is here, and it's going to happen. And again, that it frightens me when I talk to business people and they don't understand the risks associated with the cloud. They only see the relief of not having to deal with IT. So I think one takeaway is that's an attitude that a lot of business people might have, and we need to be able to discuss that attitude with them and enlighten them on what the risks are. And then maybe the other takeaway is, again, we're perfectly positioned today to get in front of this It's not that hard to come up with this kind of a framework for your organization and to start the communication about what makes sense in moving into the cloud.
Okay, thank you, Mike. The next question, which area do you see the most growth in demand around the adoption of the cloud? Integration, BI, security?
The most growth in adoption of the cloud?
Growth in demand around the adoption of the cloud.
Wow. If I understood the question correctly, I'm not sure I understood the question, so I'll give an answer to both of my interpretations. One is what might be the biggest issue that cloud providers are trying to address in order to help increase demand, and that would be security. And again, I think the Cloud Security Alliance is a great step and is taking some great steps in helping with that. In terms of the use of the cloud, what's the biggest growth in demand of the use? I still see that around the infrastructure as a cloud, so things like Amazon Web Services. I still see that outpacing software as a service, although software as a service is growing quite well.
All right, thank you, Mike. I think we have time for one more question. You seem a little skeptical. Is that a proper reading of your opinion of the cloud?
I would rather use the word cautious than skeptical. Again, we're using the cloud right now to do this webinar, and the cloud has provided companies that could never afford a whole array of capabilities to bring those capabilities in-house and to get things and to be able to focus on their core competencies and to get the things that aren't their core competencies as services. So I'm all for the cloud. I think we just need to adopt it intelligently. And so I want to help enterprises make sure that as they adopt the cloud, as they look to the cloud to provide value, they do it in a way that actually does provide value. Again, the cloud is here. I use it. I think it's going to revolutionize a lot of aspects of IT. And as architects, our job is to understand the trends and be ready for them. And so I hope I've been able to give the audience some ideas about what they can do to explore the issues and then to address those to be ready for bringing the cloud into their enterprise.
Great. Well, thank you very much, Mike. On behalf of everyone at Cutter, I'd like to thank you for joining us today. If you have further questions or comments about the content presented in today's webinar, we encourage you to call or email Mike at mrosen@cutter.com. Please visit cutter.com and go to the events section where you can register for other upcoming webinars and events.